announcement is we'll probably do this next month. So also, if you're in the Python channel in the KnoxPy Slack, Mike Driscoll is going to send us some ebooks, and let's see here. So far, it looks like his Python 201 and creating GUI apps are the most voted upon, most requested books. So I'll probably ask him to send some PDFs or ebook or whatever format he has of those two, unless anyone's dying to have one of the other books on there. I'll send them something after this meeting, actually, about that.
A question. So is he just offering maybe a couple of books, or is he, I mean, how does that work? Or can we just say we want these 4 books? Because
he initially offered the physical books, and he said, I have Python 101, 201, and the creating GUI apps. And I was like, well, I'm not sure when I'll actually physically see everyone again. So he said he offered to send the ebooks, and I'm assuming, I don't know if he's going to put a limit on that or not, but I was going to ask at least for 2 ebooks for each. So 2 Python 201 and 2 creating GUI apps ebooks, so 4 total. But I don't know. I'll see how many he wants to give away.
Okay.
Yeah, that's all the announcements I have, unless anyone else has any announcements before Alex gets started.
All right. Yeah, so just going to plug to on the 3rd, so KnoxPy's website, if you have any more info or other stuff, generally he'll post the different events, so you can find out about tonight's thing and see the past events stuff there. So it's pretty cool. Yes, let's see here. I need to read some of this. There we go. Okay, and I also run a group on the 3rd Thursdays every month, Knox Data Science Group. We had a virtual call 2 weeks ago, and you can find that video on KnoxDev's YouTube channel. So yeah, you can find that stuff there. But yeah, we'll have we haven't announced yet what our event's going to be in 2 weeks, so we'll probably have that here soon. Finally, KnoxDevs, if you haven't heard about it, it's a group that combines all the different meetups in town. We have a Slack team that you can join, and if you haven't already, you can go to the website knoxdevs.com, and you can scroll down and get to the link to sign up. But otherwise, with that, I guess I'll go ahead and get started. So thanks everybody for agreeing to set up to do this. I thought we didn't really have a talk set up, so I figured why not have something that's about current COVID-19 situation, but hopefully in a fun light. And I got some good meme-worthy things included in this slide talk, so hopefully have a little fun, nice little break from current stuff. So anyways, I'll get started. So yes, so Waffle House. So I'm going to talk a little bit about just the background. For those that not be familiar, we are recording this talk, so it'll also be on KnoxDev's YouTube channel by tomorrow, hopefully. So I'm just kind of walk you through a little bit of pandas, geopandas. Most people, I assume, are probably really familiar with pandas. You may be a little less used to geopandas. I'll just kind of briefly talk about that a little bit. And then I'll go into a bit of Jupyter Notebook. Unfortunately, this week I did not get a chance to turn it into a web app, but I got some content in that notebook that we'll kind of walk through, and so hopefully I'll fill in. But So anyways, so yes, so Waffle House, the beautiful, beautiful location is Waffle House. So there's just under 2,000 locations across the U.S., mostly in the South. And the title of this talk is reminiscent of early 2010s. FEMA revealed that as part of their disaster mobilization efforts for natural disasters like hurricanes or tornadoes, they use a Waffle House index as a guide. And they have a green, yellow, red system of green, Waffle House is open 24 hours, full menu. Yellow, they're serving a limited menu. So you can see on that lower left picture, you can kind of see an example. And they generally doing that based on supply chain. So for the most part, they're pretty much on top of it. They're like the apocalypse-proof locations. And so part of the reason we're even having this talk tonight is just the fact that normally all Waffle Houses are open. And so in this case, you have an API that, you know, just shows all of them are open, and it's kind of boring, right? There's not really any context to that. But in this case, red means closed. So generally, let's say in a hurricane situation, you know, some of those immediate Waffle Houses in the area where the hurricane is may close or may move to limited menu. And then as, you know, damage gets assessed, you know, whatever, then they start moving back. And so, anyways, it's kind of funny to see that combination guide. And FEMA does also look at like Home Depots and Walmart, but the one that they use the most is Waffle House. So you'll notice the next couple of slides, I'll have versions of how you can get your hash browns. So in this case, country, for those aficionados, is with gravy on top of your hash browns. Anyways, so if you go to Waffle House's website, you can find locations. So they'll have like here, you can find your closest location. So I think I actually disabled here. But anyways, so you can kind of see, mostly in the South, you can see all the big bubbles, but there are some, you know, true nomads out in Colorado and Arizona that have spread the love of Waffle House to other places. And so anyway, you can kind of already start to see a little bit that they have some information about closed and open, and you can kind of scroll down. Let's just go into like the Knoxville region. So anyways, you can see where Waffle Houses are located, right? Which again, normally for locations, like the paper mill location, right now is still open. You know, for their web design for this map, you know, Waffle Houses are generally always open, right? So their coloring, you know, they don't need to indicate that it's closed or not closed, right? But, you know, they still have information. What's great is they'll have information about like who owns it, and then just the hours of operation, obviously the telephone number and location. So I was looking at this on Sunday, because I was kind of laughing to myself that, you know, with Waffle House started releasing maps on their social media pages about 2 weeks ago, start showing locations of in the Southeast of places that were closing due to COVID-19. So for the most part, the reason why Waffle House are closing locations is mostly to deal with the change in demand of, so, you know, say in like Knoxville, we have, what's that, basically about 10 or more locations. If you go to somewhere like Atlanta, you know, you have a huge saturation of Waffle House because you have a huge amount of people. And so what Waffle House has been doing is, generally, I think for the most part, they've been doing closures in certain areas to limit the amount. Probably most likely not as many people are going out. I currently, while I've been in between jobs, have been working as a bike delivery downtown. And, you know, as people are not, you know, people aren't going to work, people are, you know, working from home or other things, you know, and as well as statewide, you know, decisions to limit the travel. As you can imagine, Waffle House locations are not staying open, you know, or that kind of thing. So for the most part, they're not closing locations from having positive test case or anything like that. It's mostly just a business decision they're choosing to do to limit certain locations. And we'll kind of see that when we look into the data. But anyways, at a macro scale, you look at this and kind of like, okay, so I know some Waffle Houses are closed, but I don't really have an idea of like how widespread some of the stuff is closed. So one thing I was looking at, and I was looking through this location, was kind of figuring out how to Waffle House like build this. How are they populating all these things? And so with a good, dev tool inspector, was able to uncover, oh, there's this API with a request key that isn't unique that I can just kind of run through and pull things from. So it was like, okay, it's a pretty cool, it's something, maybe we can do something here. And so I'll share in a little bit about the Jupyter notebook. And I think GitHub is still down at the moment, but if it's not, I might be able to, I'll used to be able to update this newest version of this notebook to GitHub, and I'll put it in KnoxPy's presentation stuff tomorrow on their GitHub page. Anyways, so yeah, so this is locations. So before we get there, I just one thing to note about pandas. So as most of you are probably aware, if you've done any data manipulation in Python that's in a tabular format, you probably are using pandas. Tons of stuff that are deep inside, relies on a number of other Python packages, as well as C code. And it's pretty much the standards, what's made Python a quote unquote data science tool. One thing that's happened that you may not be as aware of here recently, they actually moved from 0.25 to 1.0. And it's not really a huge shift that really happened in pandas, but mostly it's the fact that pandas is pretty stable, and it made sense to me to version 1. The best thing, though, the fact that they moved to version 1 was that they have this new spiffy documentation setup. So if you go to pandas.pydata.org, you can now search these docs. That's really great. If you've ever used the older docs, it had its purpose and time, but the web UI and everything else starting to get kind of dated. And so it's really nice. You can kind of get this getting started. And they had all these things before, but now it's a little bit easier to find. And I really enjoy with the new docs some of the API references. It's now a lot clearer and you can use, and so it's really neat. But yeah, they actually ended up still using the same underlying source for how they were putting out their documentation. They basically just put a different wrapper on top. This is a new theme that's like a pandas theme or something. So it looks really cool. So it's still using Sphinx, but it made Sphinx look sexy. So that's nice and cool. Anyways, one of the only changes with 1.0, there's a couple of changes that are in this towards data science link. It's on Medium. One of the things is that pandas has had for the longest time dealing with like missing values. It always had like terrible defaults. So finally they fixed that in version 1. And so now if you have a missing value, they now made a special type to fit that. If you've ever had the pain or pleasure of importing data from a CSV that is generally integer types, and you have 1 or 2 missing values, everything all of a sudden becomes a float. It's really annoying when you're trying to do other stuff later with that. And so finally now it's not mucking around with your data. They now have the right types. And so there's more stuff in there. But anyways, that this link, again, that I'll include in the notes tomorrow, has more kind of information about some of the cool things that are going on in Pandas 1.0. So let's look at smothered. So geopandas, it's a really powerful tool in Python. And for the most part, all you really need to know is that it's pandas, plus it handles geography types pretty decently well as a separate column. So you have a column, and its default name is geometry. It doesn't change. And so what's nice is that you can leverage a lot of the power of pandas by now having the geography component. So it handles all the icky stuff and everything else that you can do, get into things. And we actually had a talk with Knox Data, September 2018, with a UT geography professor who's an actual geographer, not like someone pretending to be. He has a really great talk that kind of gets you really into all the different parts of geospatial computing from a geography perspective. All of it's really in Python based. So if you're looking for more info about that, this is a recording of that meetup that we had a year and a half ago. It's really great. Kind of goes into more detail, but the thing about geopandas is that not only do you have all the capabilities of pandas with doing data manipulation, it can also do the geographical transformations that you want to do. And again, it's because it's relying on lower level packages and that are, you also have to download in Python. Generally, for the geopandas is sometimes lazy on certain things you can import because it has a lot of optional dependencies. So that's kind of one thing to watch out for. A lot of times you get stuck writing something and then it'll be like, hey, this package doesn't exist in your virtual environment or whatever. And so you're just like, oh, okay, I got to install this, blah, blah. You also have a docs, geopandas.org. It's now that pandas has moved to version 1, it's definitely not as sexy, but it still has a lot of good information in there. They're just like any docs. There are definitely rooms for improvement there, and you can contribute just like you can with pandas. But anyways, it's a really great thing, and again, it's built on a couple of different underlying libraries. So, but if you want more information about those underlying libraries, you can see this talk that we did. All right, so enough talk. Let's start looking at some data, right? So, yes, in covered section, let's talk a little bit about Jupyter Notebook. So, all right, so what I'm going to show you is kind of a notebook. I'm in the Jupyter's lab interface, and I'm going to kind of walk you through this notebook, kind of explain some of the stuff that I was looking at. Again, this notebook is pretty much what I use, just kind of start playing around with it this past Sunday night at a typical Waffle House hour late at night. And nice thing about notebooks that you just get your feet wet, figure some stuff out, get kind of dirty, and then start to clean it up once you kind of figure out what you're doing. So again, we're talking about geopandas, pandas, and requests. I was playing around with Fiona. I probably don't actually need to keep Fiona to import anymore. But anyways, so this is the URL. So again, this is location.wafflehouse.com. They have an API, and then they spit out this API key. And then there's this location details setup. And while for the most part, I can actually, in geopandas, I can actually read that file directly. I'm also going to use requests in this case because there's something that I need to take out from the API that geopandas doesn't understand by default to do. And I'll kind of walk you through like what that example is. So anyways, I'm going to just show you the raw JSON format here. Let's see, tab, there we go. It's just going to pull up here in a second. Might take a little bit of time. It's a pretty big GeoJSON format. String it might take a second. All right, here we go. All right, so now I got tons of ugly, misformed JSON all over the place that I'm looking at. But basically, this kind of gives you an idea. The biggest thing I want you to just see is that this JSON format is actually a valid GeoJSON format. Again, just like how pandas and geopandas are related, JSON and GeoJSON are related. The GeoJSON basically is just a structured way to understand geometry types that you're trying to do. So polygons, points, whatever. Again, if you really want to get more into detail about those, you can look at that talk previously. Anyways, so you kind of get to see the lay of the land here. So I got a type, I got a feature, I got a geometry with that, and then there's this whole set of properties, and then all this other stuff in there. And it just loops and loops. You can see this little scroll bar. This is a pretty big file, and so there's a lot in here. Okay. So anyways, that was the API itself. So okay, so we're gonna use requests. We're just gonna get this URL. Again, because this is an open format, we don't have to provide it really any credential keys. We don't have to get fancy with that. We can just do the basics. So okay, so we have this data, and then we have this geo data frame that I'm reading in. So what geo data frame is actually looking at is, again, I can still give it pandas-like expressions because, again, those expressions have been inherited into how geopandas works. But anyways, so I can, just look at the head. Just want to get an example of what this looks like. I can see that I have all the same names, which is not really useful, but I have these slugs that kind of give you an example of state, city, and like the number of the Waffle House location. And you can kind of see some other things, and so kind of some other things hidden in here. And obviously there's 26 columns, so, and I'll talk about that in a second. But anyways, you can see these other great things they have in here. A lot of this stuff is just repeated information. Okay, So I want to see these columns because again, my default in reading in, it's only going to show me a certain amount of columns. So, and you can probably change that. But anyways, here I kind of see all the stuff I have. So I got name, ID, branch, slug, blah, 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 all this other stuff. So I'm looking through this and I'm trying to figure out, okay, I want to, again, why am I looking at this API? I want to see if stores are closed. So if I go back to like, just again, looking at the raw JSON format, and I just type in store closed, I'm just going to search through it. Actually, it might be, oh, hold on, actually, I think it is closed. All right, cool. So, okay, I'm just gonna start searching through is closed, and I can see here pretty quickly that one of these locations is closed. So it's like is closed true, blah, blah, blah. And if I look up a little bit, I see that it's under this special hours of operation. Okay. And so when I go back and I look at my columns, I don't see special hours of operation. And one of the reasons that I don't see this is that just like you have with pandas when you import things, it's like a CSV or something else, you can be very explicit with how you want the import to happen, or you can allow pandas to infer, what are the contents you're trying to read. So the same thing's happening here. What ends up happening is that because the JSON that we're getting isn't actually, it's not uniformly formatted. It's formatted somewhat lazily, which serves the purpose of Waffle House. I'm not trying to start a flame war with Waffle House, please. But for the most part, they're addressing the situation as they come to it. So they're generally not having to have this. So again, we look at this first format, we saw that for this first location that we have this array under special hours of operation connected into JSON. But let's go to the next one. We see that that array is empty. So what's happening here is that when geopandas is reading in this like 18 meg JSON file, or is being read from the URL, is that it's not actually, it's like, it's reading one that has something, it's reading the next one that doesn't have anything, reading the next one, blah, blah, blah. And so it doesn't know, it wasn't given any like special requirements or everything else how to read that, because it's a nested, further nested JSON inside of that. So it doesn't know what to do with that, so it just omits it. Unfortunately, in our case, it omits it silently, and so we don't know that we're missing it until you go back in to look at your columns. And so that's why it's always good, whether you're using pandas, geopandas, whatever, it's always good just get a look at the columns, make sure that everything you expect to be there is there. Same thing with types, with reading in CSV, especially if they're misshapen CSVs from other people, or yourself 6 months ago. It's always helpful to kind of look into that, make sure that you know what you're looking at. All right, so anyways, so we realized that, okay, we're missing that information. So that sucks. We need to figure out some way to build that in, because otherwise all we have is a location. We all have is basically just all the locations. Okay, so one of the great things about geopandas that makes it nice is, again, from a beginner perspective, is that one of the dependencies it's relying on is matplotlib. So just like how with pandas, you can do like simple plots through matplotlib. You do the same thing in geopandas. So I take that same geodata frame and I plot, and then boom, I got this little basic matplotlib plot. And you can see latitude and longitude are plotted correctly, and you see all these points. So just a big scatter plot, and you can see where most of them are like. It's kind of similar to that map that I showed you earlier of all the pieces that are in there. Okay, so let's take a look at what geopandas actually read in, because we just saw that there are some things that are missing. So let's see how it actually interpreted what was being read. So let's go, I'm going to choose location 3, because I just want to see what it looks like. Okay, so Waffle House, so again, location 3 in this index. Again, I'm just trying to get a feel for the data. I'm not trying to find anything particular. I just want to get a feel for what things got picked up by geopandas. All right, so turns out number 3 and how it's being formatted is a Gulfport, Mississippi location that Waffle House has. And I can see that geopandas, when it encountered nested arrays, it still included those. So if you look at hours of operation, we can see that there's actually a nested dictionary inside this column. So that's cool. So that gives us an opportunity to pull those pieces out. But unfortunately, because of that change in format in special hours of operation between all those different feature sets, it got omitted. And so we couldn't take advantage of that in piece. But you can use like time zone, blah, blah, all this other stuff. But what's kind of cool is that, again, when you kind of dig down into storefront, you can actually find like the manager's name for each location across the country in Waffle House, which is kind of funny. All right, so remember that I did that request. Remember that I actually requested data, and I got it in a JSON format. So I'm going to do something with that request now, and I'm going to split it into something metadata. Again, just repeat of something else. And this data, as I can see here in Jupyter Lab, is contextual help. Again, request gave me a response object. And so I need to take that response object and I need to serialize it to JSON because I know it's a JSON stored inside an object. All right, so I got metadata. So again, I want to go to metadata. And so let me go back to the JSON. You can kind of see that, so again, let me go back to the top. So again, you have this properties subset here. And you have a name and all this other stuff. And so you have these kind of nested lists that's kind of going on in here, right? So I want to make sure that I have something that I have the right spot. So I just want to do a test. So I'm going to do a metadata, and I'm going to go into features, because again, that's where everything's being nested inside. And I'm going to choose the third one, again, because in features, it's an array of all 1,967 locations. So I'm going to choose the third one. The beautiful thing about JSON is that you can bastardize it to your needs of this like really ugly segment, but you can kind of just peer through and quickly make sure you got what you needed. All right, so now I'm in the actual feature. I'm gonna get properties and slug, and I want to make sure that matches, like I have the right sequence in my mind of like how to break through this, because again, I need to find a way to pull out special hours of operation because I don't have that in my geopandas. All right, so I got slug, look at that, Mississippi-Gulfport-201. That matches what I expected in my geo data frame. So, okay, I'm reading through this correctly. All right, so again, I need to pull out if this is closed or not closed, because that's being stored as a Boolean, true or false. All right, so I'm just gonna make up some random lists, and I'm just gonna peer through in a for loop, and say, okay, I need to look for every feature it's inside. Again, metadata features is all 1,967 locations. I need to basically extract that from that nested dictionary that's inside to get what I am looking for. But remember that because special hours of operation is not beautifully formatted for every single feature, this is a good time to use a try except piece, which you probably should use anyway, but you can't get away with being slightly sloppy. You just need a couple extra lines of code just to kind of deal with that. So I'm going to try, because again, for some places, I'm not going to actually have a special hours of operation. And the other thing that's kind of annoying with this particular piece is that special hours of operation itself has an array. And so inside that array are, basically days of the week, and those hours we're recording to that. And they're able to use that for their map. Because again, this API is strictly just being used to build their own map for their website. It's not being the publicly shared, out there to be used in a RESTful type format. I'm kind of taking advantage of the fact that it's available. So anyways, okay. So I just need to link it in. So, okay, all right, I'm gonna make a slug, because I want to, again, slug is an identifier. I can count on the fact that slug is going to be unique for everything, and it also provides me something that's contextual. I have an understanding of what that location is because of how Waffle House decided to create their API. So again, I can use it. So give me a slug. So again, feature properties at the properties level in that dictionary, I can find slug. Great. So I'm going to update this and with this dictionary. So again, what I'm doing here is I'm taking advantage of dictionaries, and I'm going to basically do an update and I'm going to build this to append to a list. In this case, what I'm doing is you can create pandas data frame in several different ways. In this particular format, it makes sense to just keep in a dictionary format because I'm basically needing to, for every location, I need to actually build something there. So for this particular case, I could actually just use a value instead of dictionary, but I'll show you a little bit later something else that we might want to do to add a little more nuance to this analysis of why it made sense to use dictionaries to build my data frame. Either way, you can do whatever, but this is just one way of doing it. All right, so again, I need to try. So I'm looking to make sure that this exists. If this special hours operation, which should all be there, I then want to look at the first index inside that array. Again, if this array is empty, like it is for some of the locations I showed you, this is going to give me an error, right? It's going to give me an error because you can't find that. So that's why it's in this try except. All right, so then I nested inside. Again, how I figured out this, I just kind of plug and chug, look through the API, look through the JSON format and figure out what the right nesting is. And say, okay, cool, they have this variable is closed, and it's true or false. Great. Update it, boom. All right, so when that doesn't exist, well, that means that if they didn't put special hours operation in, my assumption is it's wide open, it's open. So it's not closed, it's still open, so don't even worry about it, append it, boom. All right, so I append it to this list, and now I can give that list to pandas data frame, and boom, I got a thing here. So one thing I can actually do is now I can look at this low closed, and okay, boom. So one thing that I showed you a little later that I'll get into, I forgot that I already ran this. But anyways, you can see the slug, you can see it's closed, ignore the other column, but obviously now you'll see where I'm going with this. But anyways, so slug, true, false, blah, blah, great. I also already inherited that true and falses, so I don't have to worry about that. Great, got Boolean types, awesome. All right, so one of the great things we can do with pandas now is, all right, because we're using geopandas, we can just merge. So we can take advantage of left joins. So geopandas isn't as verbose in terms of how they chose to write their properties of geodata frames. So in this case, when you're doing a merge, is basically what you're doing in a left join situation in pandas. And I think pandas still uses merge in an older format as well. So anyways, the nice thing about it though is that boom, I can read it in. And again, I'm gonna look over here. Again, contextual help is really nice in Jupyter Lab. You can kind of use this. So I can look at the doc string. So all right, so signature, I got these args. I'm gonna merge two geodata frames with a database style join. Perfect, that's what I want. So again, I'm gonna return if a geometry column is present, otherwise it will pass as a pandas data frame. So the nice thing is it actually underneath actually handles the fact of whether you're merging with geodata frame or just data frames. But anyways, so the nice thing is that in this case, I'm gonna say slug because again, if you go back to my geodata frame, I have slug, which is why I chose using that. Again, you could choose something else, but I figured that branch doesn't tell me what I'm interested in. Slug seems to be pretty good. All right, so let's merge it, boom. Okay, great. And one other thing that I want to make sure, and this goes into the fun things of geography, is I want to make sure that I know that this GeoJSON format that I'm being given and defaults to basically this EPSG value, which I won't go into detail. If you're really interested, you can find out more information about it through that talk and some other stuff. And I can point some other, and if you have questions, I can kind of walk you through. But basically, GeoJSON several years, or I guess now 8 or 9 years ago, decided that we should, as a sane choice, we should all default to the same projection that we're using. So that's what the CRS value is. It's a coordinate reference system. All this needs to say is that I'm projecting it to what I'm interested in. So in this case, actually, one thing I kind of said wrong. Okay, so actually it's using a different CRS. Sorry about that. I actually realized that I did not include that. Hold on a second. All right, so this is actually what that CRS is defaulting to. So I'm taking that for granted that the GeoJSON format was installed in this particular format. I'm going to talk about in a second why I'm going to reproject it, but suffice it to say, this is what's going on. It's this particular coordinate reference system. That's what's being inherited in this. So in this case, for reasons I'll explain in a second, I want to reproject this into something that looks a little better on screens. There's a fun XKCD about projections, and there's tons of memes about that. So if you really want to get down a rabbit hole, I wouldn't need to do this at all. I'm just doing it because I chose to. So anyways, so okay, so I'm gonna re-coordinate it to what's an outburst projection. So it makes it look like the Montana not so straight, and it looks a little better. Anyways, so I'm gonna choose this projection. Again, I decided to do that. And boom, let's plot it. And now, because I had merged previously that information if it's closed, I can now basically do like a small colored, basically geoseries of points. So again, that if I go back to the geojson, it was giving me in geometry, it gave me a type points and the coordinates. Those coordinates are in Latin long. All right, so now I can project it, and now boom, I can see all these points. And so now I can see false and true. I can get more information with that. The nice thing is with the plots, you can add some context to it. If you want to get even more sophisticated with it, you can actually just feed this to a matplotlib plot setup, and you can get all the features that you love with matplotlib and do stuff even better. But it will basically understand the format that you're trying to use. Anyways, okay, great. So now I have this true and false. Great. So now I have this overall look at the map. In this case, true is a pink color, and that's saying that they're closed. So you can kind of see some locations that are cross. And so this is data that I just updated today. They're adding locations every day. All right. So now I want to get like a num close because I'm interested in with like, all right, I see all these out there, but how can I do something with it? All right, so I'm going to basically take those closures and begin, because this is geopandas, we can use pandas-like statements that they've put it in. And so we've seen this query. So I can actually I can query the information, and you can do other things, but I like using query because it puts you into like a SQL-like statements, writing things, and it makes it nice. So I want to query what is closed equals true, and I'm going to count within that series. So I'm taking advantage of the fact that I can kind of clink on different things I want to do. So basically what I'm doing is I'm taking this geodata frame and I'm just finding that are true. I then just piece off the is closed, that column, and then counting. So now I've turned this geodata frame into just a series. So I'm just do a count. So boom, so let's take a look. So what does num closed here look like? All right, 624. That's pretty substantial, right? Again, this is the this is a location that like never closes, and so 1967 locations are always open. So to have almost over a quarter of all locations closed is a pretty big number, right? And this number's going up. All right, so again, I just want to get the total locations of all that, and again, this is closed and count, other pieces in there, because again, I just wanted to make sure that I have all the numbers. Again, 1967 is what that number should be. And so we'll just do a double check. All right, boom, 1967, that's what it should be. Cool. Geopandas didn't miss anything in there. We have everything in there. Great. All right. So one of the things that you have there is, okay, so now you have this map that you can make. And so you can kind of say, all right, 624 of 1967 locations are closed. And that's what Waffle House has been showing on Facebook posts and Twitter of kind of the locations of stuff that's closed with that context in there. Okay, so, all right, but remember that the FEMA index, let's go back to the FEMA index. Remember, they were doing limited menu, right? Well, if you look through the API, there isn't really something that really shows whether they're doing limited menu or not. So we don't have like a true representation of the FEMA-like index, but we can use as a proxy of if they're not fully open, but they're using limited hours. That's kind of almost like having a reduced menu or a similar context of how Waffle House is changing in response to COVID-19. All right, So again, the other reminder too that I don't think I talked about yet, locations at Waffle House are open. They pretty much now have uniformly all have gone to a to-go curbside pickup. And I think in some locations they're organizing through like one of the delivery options to kind of do some deliveries, but I think for the most part it's just curbside to go. So you can show up, get some stuff, and leave. So when they're doing 24 hours, it's all in curbside to go. They're not letting anyone sit inside to dine. All right, so basically I'm going to do open 24 hours, open reduced hours, and close as kind of an analogy of this Waffle House index. So I'm going to take that same statement I did earlier, right, of is closed, but now I'm going to add if there's also a 24 hours option. So one of the things I'm going to do is instead of writing 2 loops or anything else like that, I can take advantage of the fact I'm already peering inside each feature, right? And because of that, I also don't need to write 2 separate try, catch, or catch statements either, because reality is, or the thing is that if special hours of operation isn't empty, then there will also be a location of 24 hours. And the nice thing is that because it's all in a try statement, I can basically break out in that exception and still handle it. Now, again, this is based on some assumptions. If this format was less formatted and it was even more Wild West, then you would probably need to stick to a double try and exceptions loop. But for this case, we can feel confident that if it has the information about is closed, true or false, it's also going to have the information about 24 hours or not. And that's something that we can rely on. All right, so what I'm going to do is I'm just adding this feature here of saying, hey, if it's not closed, so if is closed is false, and I could also make this a variable, make it a little easier to read, but just for the sake of the thing, I just put it like that. So I'm going to say, all right, try 24 hours, it's this feature, boom, and I'm going to say try 24 hours. So I think actually I could actually make that statement even better, just try as is closed. Yeah, that'd probably be even better. All right, so anyways, so I can feed that in and then boom. So again, because I was using a dictionary format, this helps build in and I don't have to do anything, I don't have to change much for the code, which is nice. I don't have to change anything else. So, all right, so I'm gonna feed this extra dictionary of 24 hours. Again, I format it this way because that's how the Waffle House API used it. Again, all I want is just the data, just trying to make it simple. You can choose other things you want to use for your columns. But I can feel that it's pretty safe. All right, so again, if it's not closed, are they still open 24 hours? Great. If they're not, then they're not open 24 hours. Is that something else you need to put in? And something else you could do is I didn't do in this particular notebook, but you could do separately, is you could actually build on this and also see are hours different? How many hours are they open? And you can maybe even build that into a separate column, whatever. Anyways, great. So I'm going to update this dictionary with these 2 formats. You might be able to do this in yeah, it looks like I could have done this in an array is what my contextual help is showing me. But anyways, whatever. All right, so great. So now I can append it. Boom. So again, now you can see I already run this. So now you can see that hair. And again, so let's see. I'm just going to run this again. Boom. Oh, give me something else that I just did. Okay, well, forget about that. Anyways, all right. So anyways, so I'm going to take that and I'm going to take this in here and I'm going to merge it. And I'm going to merge it on that slug. So again, now I have this thing where I have a closures and I have 24 hours. But if I'm thinking about this of how I want to actually display this information, it's really, I don't want to try to display is true, is false for 2 different variables. The context is if a Waffle House location is closed, it doesn't matter if it's limited hours or not because it's closed. So really, I need to take these two different columns and actually just merge them into one column. So what I'm going to do is basically I need to make a new column called status, and then say, all right, is closed is true, that means it's closed. Is closed is false, and 24 hours is false, then that's limited hours. And if it's closed is false and 24 hours is true, then it's open. That's the basic, logic, whatever, right? One thing I was going to do is normally I use df.applies, but some Stack Overflow gurus / how the internet works said that was dumb. You should use this. this is faster. So, okay, for the purpose of what we're doing, why not? So anyways, I'm using numpy.select. So I just need to import that because I didn't import that in the beginning. And so, okay, so I want to make this weird kind of setup condition. So I got this thing here of GDF closures is closed. And then I'm doing this logical and. I think I could do this less ugly. When I was trying to just quickly do it a couple days ago, I wasn't doing the right syntax or whatever. So I was like, all right, fine. I know that this particular way works. I'm sure you can probably make this a little better. Anyways, again, I'm just trying to take that same context and apply it here. And I'm going to give it outputs. So the nice thing about numpy select is that this vectorizes how it does it, and that's how this one Stack Overflow commenter kind of suggested that this could be used to use. And so the nice thing is it's already vectorized, so it's going to do it quickly. It's great. So what I'm doing here is I basically say, all right, numpy select. Again, look at contextual help. I got a condition list. Boom, I built that. I need a choice list. Boom, I've done that. So again, whatever happens here is being mapped directly. So think of it in terms of a mapping kind of idea. I'm mapping this condition to this output. That's what I'm trying to create. Okay, awesome. And then you can do a default. I just made some dummy variable. In this case, I'm going to check to make sure that it's not there. So I'm just going to use it just so I know that it's not there. And again, I don't want to make it like open or some other default because I don't want this to pass silently. Again, I want to make sure that I did this correctly. So anyways, okay. So I'm going to do this numpy select. I'm going to do these conditions. And before I do it on my live data frame, I'm just testing it out just to make sure. That's a great thing about Notebook is you kind of play around, make sure, all right, the thing that I think I am doing, am I actually doing that? All right, so I'm just going to play around with this. Okay, cool. Let's look at this head. Let's do 20. Because in this case, I actually had the first limited hours didn't show up to the 20th location stocked in Waffle House's API. So I needed to make sure that I could make sure that I mapped that correctly. So great, I got close, opens, and some limited hours. Okay, awesome. So now I'm like, okay, now I have this series. Let's go ahead and add the column. So take my GDF closures. Again, I have these rows and columns. I'm going to add status. Boom. So now I'm going to do number of limited hours, and I'm going to do the same query statement. So now you following along will know like what's going on. Boom, now I got 109 that are limited hours. So if you look back up, I had 624 that are closed, 109 that are limited hours. So pretty much now we're getting down to about 55% of Waffle Houses are still open as usual. And about 45% of locations are impacted in some way, whether they're closed or doing limited hours. Okay, so again, I wanted to have this different projections. I'm doing that. And then boom, let's plot. Okay, cool. So I got this categorical. And again, I chose this one color format. This probably doesn't look that great. We'll see. But anyways, so we have this close, limited hours, open. And so now you can kind of see some more context that, and again, yellow is probably the best choice here, but you can kind of see some locations around here that they are impacted in some way. And there's actually a location closer here in East Tennessee that's actually being impacted. Okay, so cool. So now we see a more nuanced picture, but let's kind of add some shapes, some other stuff to there. So there's kind of two different ways to do this. So, well, actually several different ways, but from sake of argument that I did it two different ways. So again, the fact is that geopandas relies on matplotlib, so we can make it look a little better in matplotlib, add some extra features to it, make it a really good map. Or if we want some interactivity, we can actually use Plotly. So Plotly is a company, for-profit company that does a lot of projects related to data visualization. They built a tool several years ago that's basically built on D3, which if you've ever had the pain of or pleasure of D3, it's definitely a pain and pleasure type feature. You basically can build super awesome interactive visualizations, which is how New York Times, Washington Post, several other outlets make really, really cool visualizations to view on the web. And Plotly basically takes that, wraps it, and allows you to play with it in your language of choice. And they really, really like Python. And so Python's their go-to for a lot of stuff. So anyways, all right, so for this case, Because I put it in this other projection, I need to put it back to that projection, to the standard projection that Plotly would expect it to be in. Again, that's how I get lat longitude again, not this other format. And okay, so that's just what that is. Okay, so I'll get back to it in a second, but basically one thing I'm going to do here is that geopandas isn't really still natively, still isn't really supported with Plotly, and it's still kind of work in progress. But the nice thing about Plotly is that they have a really great online community. They have their own discourse server that's basically like basically the 20th rendition of forums. That's now in a nice format that fits the age. But anyways, you can get directly on with Python developers for Plotly and everything else, and it's kind of cool. But they also have a lot of open contributions on GitHub, and so you can do pull requests there and add stuff to it. But for the moment, they don't really play well with geopandas, and so you kind of have to do some shenanigans. So one of the things I'm going to do is take advantage of how points are done. So this is kind of obscure, but basically I'm going to make Latin long separate from my geometry. So just a refresher, just to make sure I lost anybody, is if you look at geometry for how my geo data frame is organized, it's using what's called well-known text. Again, it's a geography specification, but basically points, polygons, multi-points, lines, blah, blah, whatever. Our particular case, everything we have is a point. So this point and then Latin long. All right, so I got points. So how it turns out is that this is actually, geometry is a column of point objects. So what I can do is, there's a little known tool that I had to definitely Stack Overflow to find out how this actually works. Turns out that point, latitude is X, longitude is Y, and so you just do, if you go back, you can basically pull out with an apply statement .x .y. It's a weird, obscure thing how they use points. The reason why they don't use Latin long is that because well-known text and points can be used for other representations, not just the globe. And so X and Y made sense for their particular case of how they want to use it. You can also do Z. There's a third dimension for however stuff that you're kind of working with. But anyways, so what we're going to do is that we're actually going to unpack that object for each row. And so we're going to use apply. We're going to use a lambda function. And so again, if you haven't used lambda functions a lot, again, you're just applying that to each row to pull it in with some name. So anyways, I got this point object, and I'm going to need the X, need the Y, and that feeds it to Lana lat. Great. So now I got this data frame. So because I no longer have, or I now have longitude and latitude as separate from it, I really don't need to keep it as geodata frame. It doesn't matter because geodata frame is basically a wrapper on top of Python or Pandas data frame. Plotly just sees data frame and says, "Cool, good to go. I know how to work with this." I'm sure there's more detail underneath, but for the most part, it works. But if you want to be strict about it, and maybe there's a reason to something else that I'm not aware of, you can also make sure that this is strictly a data frame. All right, so let's just look at this again. The head. So okay, cool. I have this geometry. I still have my statuses and everything else, but now look at that. My longitude and latitude have been pulled out of my points. Awesome. So one other thing. So Plotly, again, they really treat Python like a first-class citizen. It's really cool. So one of the things that they did to simplify some of the tools of how you use Plotly, I'm going to actually just kind of show you what Plotly Express looks like. Basically, they made this kind of terse, high-level API for you to just kind of get your hands dirty. What it is that it's basically a wrapper on top of Plotly's own calls. And so Plotly was originally designed for D3 and for JavaScript. So a lot of the conventions that Plotly uses for some of the way that they write certain things is almost in a JavaScript-like syntax. And so it can be kind of something to get used to when you're generally writing Python statements. So one of the nice things they did is they basically took, it's not fully featured of everything Plotly can do. So for those, you're still going to use like the Plotly's underline express or underline functions. Let's say that you don't care about that. You just want to use, I mean, for the most part, we have our data. We just want to quickly look at it and we want to use things. So Plotly Express is this thing they created about a year or so ago, maybe a little longer than that. And again, it's basically high level and it operates on tidy data. And so if you came using data analysis from an R perspective, like I have with tidyverse things, this kind of syntax matches closer to something that you have done with like ggplot2 or something else. And so for me, it's easier to understand of like, okay, take a data frame and then I'm going to push it into my plot that I want to use. Anyways, it's great. A lot of different things you can do, and you can just import this and you can kind of get dirty very quickly with a couple lines, boom, build what you want to use. It's great. Plotly, on the other hand, if you didn't use as data frames, and again, this is relying on the fact that you have data frames you're using, you would have to specify more verbosely, oh, I want data frame this column, data frame this column. Whereas in this case, just one line, data frame. Oh, okay, I now know that data frames you're looking at, X is going to correspond to that column, Y corresponds to this column. Perfect. All right, that's Plotly Express. So, all right, so I'm going to give it a figure, and I'm going to say, okay, I want to take this data frame. Here's my latitude and longitude. It probably would interpret that otherwise, but just to be on the safe side, make sure that it's got it. This is a scatter geo type. So it's a geographic scatter plot, and I want to have markers that are colored on a certain thing. So I want to make sure that it's there. And so again, that color is status. So again, close, open, limited hours. And then some other stuff, just kind of make it look nice. I chose a certain color map. Probably use a better color map than this, but that's what I used. And let's see here. Make sure this plots again. All right, cool. So now what I have is I now have this overall index, and I can now actually see what's open, what's closed, and now I can have this like fun, like visualization that's relatively easy to do. This did take a lot of lines of code, right? And I could actually, Plotly has some other information of how you can actually export this. And so let's say I want to put this on a website, which I hopefully maybe do tomorrow. If I get the other part that I want to do, I can actually make this a visualization that you can just use. Anyone can just direct you to a website and then boom, play around with it. Because again, what's nice here is again, I'm using Jupyter Lab. I can play around with the interactive output and just kind of see what it look like rendered on a website. Anyways, you can add some stuff. So you can do, I actually didn't format this correctly. I need to add some custom data for the city-state thing to come up. But anyways, you can kind of see open, close. What I would probably do if I was going to make this like a full featured, I would probably have like the location name as like my title for my pop-up and get rid of the lat longitude because you don't need to know that. And then you have some other information about the hours that I already have stored in there. But anyways, you can kind of see some of the stuff they have going on. And so what's kind of nice is that, let's say I want to look at just where the limited hours locations are. You can kind of see where those are geographically. And again, these are just tools that Plotly has out of the box. That's why I like using them. But again, there are several other great options out there for you to use. I just personally like Plotly. I think they do a lot of great work. Anyways, you can see a lot of locations. The nice thing is that Atlanta is still well served. There are many Waffle Houses that are still open 24 hours, providing the demand that we all need. And then you kind of see like where the closings have happened. So you kind of see that the closures have kind of been more widespread, whereas a lot of the opens are mostly regarding to the south. So you kind of get that kind of context. And while for the purpose of this talk, I didn't get a chance to add other pieces of data, you can kind of start to think about what other data sources you could cling on to this. Like maybe it's number of cases, COVID, maybe it's day in which orders were enacted for stay at home, in certain states, because again, it's been a state-by-state basis, especially location or counties by counties. And so you could maybe add some of that other context from these other rich data streams that are out there right now to kind of add context to kind of provide insight into, why are some of these locations closing and how that's changing. So anyway, so that's the cool Plotly way of doing things. And again, you can kind of turn these back on. Again, all these things, tools that they build in, it's kind of neat. So anyways, so one of the things you'll notice though is that because I was using Plotly, it gave me this all great like layout of having the projection I wanted. I didn't have to reproject this data. It just had lat and lon, and then it projected it how I wanted it to. That's kind of a nerdy thing, but something you can do there. You can get kind of cool with how you want your visual to look like. Very neat and pretty syntax. And again, you can see their JavaScript origins for some of this. A lot of the stuff is still kind of written, something you would more see in a JavaScript type format. But again, just simple dictionaries for a lot of the writing. And you'll notice here that I'm actually have done mixed way of doing stuff. So you can either write something as a true Pythonic sort of dictionary, or you can write it in terms of a JSON dictionary in some ways, and it will interpret both. So it's kind of one way you kind of work around. Generally, this will happen a lot when you're copying and pasting from other stuff and you'll use, but you kind of see some of the things you can do. All right, so that's a Plotly way of doing things. That's a way to do interactive visualization. But let's say you don't care about that, or let's say that you have a really awesome thing that you use in matplotlib and you want to use that, power to you, right? All right, so again, if you remember this geopandas data frame is just the points, right? But you don't have the context of like where that is. Obviously you can kind of make out the coastlines of where in the south, but you don't have the context of to understand that, oh, this is in Colorado, this is in Arizona, right? So let's build in a geojson. So let's read in a shapefile. In this case, geojson format. It's gonna be a states background. So again, states background and plot. Boom, you can see this huge lat lon of plot that's been put out. And you can see that Alaska's in here. See Hawaii, which is stretched out. The reason why this is fully stretched out is that there's some Aleutian Islands that are positive, and it get this huge thing. Anyways, whatever. That's a talk for a different day. So I just want to, because Waffle House is not in every state, even though it should be. I don't need Alaska, Hawaii, or Puerto Rico, which for this particular GeoJSON that I downloaded from GitHub had. So I don't need those. And so in this case, I just want to do a location, and I just want to remove. And again, I'm basically querying, essentially. That's another way of doing this. In this case, I'm using location to kind of work through that. But anyways, I can basically say, hey, don't include those three. I don't care. And I want to use this different projection, similar to the one I just used with Plotly. So that's what that projection is. Then boom, here I got this plot. And now I have, the lower 48 all here, and I can see those locations connection. Obviously, it's matplotlib, so it's a static image. You can add some interactivity if you really like pain. You can do that. But for the most part, this gets you pretty close to what you're looking for. And you get a set a title. And so now I have this really cool formatted thing of locations. Let me make sure that I actually ran this part. May not have. Yeah, okay, boom, updated. So that's the data that we have today. So you can see there's a couple more closings than we had the other day. But again, it kind of gives you a context of some stuff you can do. So again, overall, what we've done here is we've just taken something that look into web scraping, and then kind of contextualize that with like, how can we actually look at this data and this information? Again, Waffle House is just using this to, when you go to their website, trying to look up your nearest location to you, just to give you accurate information of current closings and openings. Again, because if your go-to is Google Maps for location hours, and these, tested times, depending on how quickly that's updated, that information may not be correct, right? And so, but what we've done is we've taken what they've used and we've actually curled it for our own purposes. And this was to get an idea of actually how many closures are happening. And again, from a data science perspective, you could take this information and then contextualize it further with other data sets, or you could do something like more kind of geospatial kind of concepts of thinking about population density, where some of these locations are closed, you know, where are all the locations within counties, again, using spatial references of like capturing based on certain counties or whatever, you know, where the most closures are happening in there. And so that's all the things you can kind of think about, contextualize. So with that, I'm going to, like I said, I wish I was getting a chance to get a web app together to do it. I was close to doing it, and then I just ran out of time. But I hope to put that together hopefully in the next week or two. And I'll send out a link for that so you can kind of see. What I'm hoping to have is have like a small like free Heroku instance that gets bounced up, and so you can see like an interactive web map every day of like locations and where those are during this time. But with that, I'll turn it over for questions. So if you have any questions or something else that I can explain a little better, let me know.
How often is that map data or the data that you're pulling from Waffle House's URL?
So
how often is that updated?
To best of my knowledge, I think it's only being updated once a day. I don't have, if I look at the, trying to think, I don't think I have information of when it was last updated. I don't think that's in the JSON they provide. And so I don't have a clear idea of when they last update. So if I go, let me go back to this. Okay, we go. So let's see here. Let me go to the bottom. See, even at the bottom, I don't actually get any information about where. There's nothing else other than this feature set. There's no information about when this last was updated. So what I was thinking about for a web app for Heroku is, because this data is only changing once a day, to best of my knowledge, it makes no. It's silly. Probably maybe it might take down their API to like cache more, to hit it more than once. And so what I probably would do is like cache it, store it in a Postgres or something else, and then just provide that information for that day. One thing I haven't done that maybe I kind of wish I had done is start to actually cache this information to see a visualization over the last 2 weeks of how many have closed. That would have been kind of cool. Didn't get a chance to do that. But that'd be something else you could do.
Hey, Alex, can you show where where you signed up for the API?
So in this case, I actually didn't sign up. So what I did was when I went to Waffle House's locations, and I used like web inspector tools on Chrome. It's Chrome Dev. This was the API that it was. This was the string that it was searching from, and so I just copied and pasted it.
Oh, okay.
Yeah. So it turned out that this worked. It's not geo locked or something, and it's not shut down or anything. So I was able to just basically rip it and use it.
Oh, okay.
And so in this case, because it's only a get, and I'm only getting the requests, I'm not able to send anything to it. I think for the most part, this is probably fine to do, because I think it's just static. I can't, nothing that I can do. That API key doesn't give me permission to like change anything. I believe it's just get.
Have you noticed that if the API key has changed at all, or if it's the same one?
I don't know. I was wondering about that. I honestly, once I had this worked and it kept working, I didn't even check back to see if I like reloaded the web page, if I actually get a different API thing. I have a reason to believe that this is just a random generated spot, and they probably have more options. So I haven't gone back and looked, but this worked. So I was like, okay. All right. Any other questions?
What do you plan to do when you hear from Taco Bell's or I'm sorry, Waffle House's lawyers?
Burn
kidding.
it down, right?
Yeah,
burn
right.
burn this GitHub repo down and walk away.
Just destroy the Zoom recording.
Yeah. Destroy the recording and everything else.
Yeah, I think it would be neat if you overlaid some of the virus cases with this, like per county or whatever.
Mhm.
Does it give the counties in there or just like the cities?
So it just gives the cities from what I can see. Yeah, I think it pretty much just gives like the city and province, and you can see there's some other stuff. So one thing you could do to get county is you could take advantage of you could do this a couple of different ways. One way you could do this is you could actually provide a geojson of all counties in the US, and you could actually do like a spatial capture of all the marker points that fit within the boundaries, because boundaries are pretty well relatively set and they're all, you know, on lat long. And so you could actually, I think that's probably as one way you could do it. You could also potentially do a zip code lookup, but I'm trying to think. I'm pretty sure postal codes don't. And they might actually. Yeah, I probably wouldn't use postal code because that might, in certain instances of counties, I don't know. You might be able to use that to like build if you had a like a dictionary of like postal codes mean this county or something. But yeah, it'd be interesting idea though. Like how many, I was thinking about that, like building like a polygon set of like how many locations are closed, and you know, compared to how many you know, cases there have been.
Yeah, I mean, Atlanta would be screwed if it's correlated to open Waffle Houses.
Yeah. Yeah, so that's something else you could do. Yeah, is definitely look at that kind of piece there. Hey, Alex, do you have a question?
No, I'm just looking at it. I think you can, if you plan to save it in like in Postgres database, there are lots of data about county boundaries, zip codes, so it's very easy to do.
Mm-hmm. Yeah. Makes sense. Cool. All right. Well, with that, I'll put a set of these slides and I'll post it to the KnoxPy's GitHub repo for presentations, and I'll include the link to this GitHub to the notebook that I have in the repo that I use for this, so you can have some of the information. And I actually will have also put requirements in there too, so you can see like what my dependencies were. Throw stuff in there, but yeah, and I will probably over the next like week or so add some other stuff to it, and if I do, I'll let y'all know on Slack some other stuff that are in there. Talk about some of the pieces that we talked about today.
Okay. Well, thanks, Alex. This was great.
Okay,
Yeah.
thank you.
Awesome.
Alex.
All righty.
All right. Thanks, guys.
Thanks. Bye.
Okay, bye.
Thank you, Alex. Bye.